Thank you. Hi. It's really great to be here today. It's been really interesting hearing everyone's talk so far. Today I want to talk to you about the readability of our code. A lot of the talks this morning were kind of very AI related. I kind of want to refocus a little bit on the human side of software engineering, and in fact we are still writing code, and the quality of that code is still really important. You know, good craftsmanship is as important as it ever has been. So a quick introduction to who I am. I'm Andy. I'm a technical team lead at Evoluted. We're an agency based in Sheffield. I've been there for quite a few years now. I've been working with the web for what feels like forever. But before I was a web developer, I was a physicist and did computational physics, which also involved programming. So I've had my fair share of seeing different code bases, both good and bad. When I'm not coding, I really love street art. I run a little website called Street Art Sheffield, so it's great to see one of Sheffield's murals on the last slide deck. It's a favorite of mine. But today we're here to talk about code. So if I was to ask a developer, software engineer, however you want to refer to the role, how do you typically spend your time at work? I expect to get a response about their writing or perhaps now generating code. Now people are using AI. Hopefully you get someone that says that they're a problem solver, because I think that's really the interesting bit about the work that we do, is solving problems. What you rarely hear is someone say, well, I spend my time reading code. But the reality is that is what we spend a vast amount of our time doing. Robert C. Martin, who's written a number of books on quality of code, has said that the ratio of time spent reading versus writing is well over 10 to 1. That's a lot of time spent reading code rather than just writing it. And I get it. When we're asked what we do, writing code is the interesting part of what we do. In many ways, it's where the deliverables come from. So it makes sense that that's perhaps where we put the focus. But we need to recognize that reading takes up so much of our time, because that kind of implies that the quality of the code we produce is really important, because we want to kind of reduce the time reading it so we're getting to the deliverables quicker. So I'm going to use two classics of literature as analogies for good and bad code bases. But before I get to that, I just want to spend a moment to think about what type of people are actually reading our code. I'm going to introduce you to 4 different developers. And we're going to start with the less experienced developer. Now, they're depicted here as someone very youthful looking, but I don't mean someone who's junior when I say less experienced. That is someone who's less experienced, and that is a correct category, but you could be very senior in your role, but still less experienced when you're put in front of a code base that you haven't looked at before. Maybe it's a new project, a framework that's new to you, maybe it's a different language. In all those scenarios, you become less experienced. The quality of the code that you're reading makes a difference to how quickly you can be onboarded onto that project. We then have the code reviewer. Now, I work in an agency space, so when we do code reviews, we're often looking at people's work who are on projects that we don't necessarily work with ourselves. So we're often hitting that less experienced scenario. But even if you are, it's somebody else's code that you're reviewing, and often just seeing it in like individual lines where you're looking at the changes in the Git repositories. And so the readability of that code on a line-by-line basis, again, is really important in terms of how effective that code review can be. We then have the stressed developer. Now, I'm sure most people in this room, if not all of you, can identify with this one. You know, maybe there's a bug on your system and you needed the fix yesterday. When we're in this state, our brains do not work at their best. You know, we really struggle to focus when we're in a stressed state. So again, if our code is more readable, it's going to make those situations easier to deal with. And then the final developer is the interrupted developer. Again, I'm pretty sure everyone in this room is familiar with this. You might work in an office and your colleague has come over and interrupted you at your desk. But even if you're remote, it might be just that extra knock on the door as another Amazon delivery you forgot you ordered has come. Each one of those interruptions is estimated to take you 15 to 30 minutes to get back to the productivity you're in before that event. So again, if the code is more readable, easier to understand, it's going to be quicker for you to get past that interruption and get back into the flow of things. So I want you to keep these developers in mind as we look at how readable code is. So this brings me to the first of the books. This is Ulysses by James Joyce. Can I get a show of hands in the room? Who has read this book? Anyone? No? Great. I don't have to stand here and feel like an imposter because I've not read this book either. Right? So I have chosen this book for a reason, because it is notoriously difficult to read. It has a reputation. So much so that James Joyce has said, and I quote, that he put in so many enigmas and puzzles that it will keep the professors busy for centuries arguing over what I meant, and that's the only way of ensuring one's immortality. So, if this describes you or someone on your team, you might need to sort of have a little think, maybe a chat to them or yourself about what code you're producing, because this isn't great for a collaborative approach to writing code. But I want to pick up on a couple of reasons why Ulysses is notoriously difficult, aside from the enigmas and puzzles. Those are the stream of consciousness and shifting narrative styles. So, stream of consciousness is this approach that Joyce used to depict his characters' thoughts in the book. Now, authors often depict characters' thought processes, and they do it using nice, focused, short, concise sentences that are really easy to read and understand. But that's not how our brains work. When we are thinking, our thought processes tend to be long-winded. We go off on tangents, we get distracted. Often, what we start thinking about is not where we end. It's lacking focus. And this is how Joyce wanted to write his character's thoughts, very literally. I've seen examples, and it results in very long sentences with little to no punctuation, and there is no focus there. And they're very hard to read and process. It's really hard to follow what's going on. And then we have this shifting narrative styles. Now, again, not dissimilar to other authors. Joyce wanted to write chapters for representing different characters' perspectives. And, this isn't unusual. This happens in lots of literature. What Joyce did that differed, though, was he wanted to also shift the way that he wrote, the literary style picked for each chapter. So you'd go from a very traditional, maybe like first or third person perspective, to suddenly a chapter that's just a poem or a script for a play. It constantly changed. And this really breaks the natural flow when you're reading through the book. And this makes it difficult. It creates a friction. You might represent some of these ideas as things you see in code. We might have very long, deeply nested code that resembles that stream of consciousness, where there's so many so many nested conditions that you find yourself becoming lost and disorientated. It's a bit like if you're walking through the woods and you're leaving a trail of breadcrumbs behind you to try and find your route back, only to turn around and find that birds have pecked away at some of the crumbs and others are blown away by the wind. You become lost. And this can happen when we have long, deeply nested code. And then we've got similar to that shifting narrative style, we can have very inconsistent styles, naming conventions. Even inconsistencies in syntax can be quite jarring when we're reading through things. It might seem really trivial, but actually these are all contributing to making the code harder to follow and read. They're all contributing to a cognitive load. I think this is really important that we understand this because people talk about clean code, but why does it matter? Our brains are really incredible. They can hold vast amounts of information, knowledge, emotions, thoughts. But when it comes to reading, we're actually just utilizing our short-term memory, and this is really limited. The average healthy brain can only remember 4 to 7 items every 30 seconds. That's not a lot. So if you think of that in terms of long, deeply nested code, you can see how you can quite quickly forget where you are. And then every time there's like this context switch, it creates this mental fatigue. And this is impacting the brain's ability to fully focus. And when this happens, we're more likely to make mistakes, more likely to misunderstand things. And this is really important that we recognize, because this is why it's important that we write good quality code. So I want to move on from Ulysses. I want to move to the second book. Now, can I get a show of hands? Who's read The Very Hungry Caterpillar? Yeah? Okay. I don't feel like an imposter because most of you read this book, and I have. I read this book as preparation for this talk. Just to refresh my memory, because I originally read this many, many years ago. But I think the reason why so many of us have read this is not just because it's a children's book, because Ulysses is an adult's book and we're all adults in the room, so that's not an excuse. It's the fact that Eric Carle wrote a very readable and accessible book. So, again, let's consider some of the reasons why this is so readable and consider how that can be represented in our code. Carl used a very simple and repetitive structure. As you turn the pages of the book, there's a familiarity about the sentences. It's almost like you can predict what's going to happen next, because there's that structure, that repetition that you can see. And he also used very consistent and explicit language. And when I say explicit, I don't mean that we've got a very sweary caterpillar. That would be a very different book. There's probably a version like that out there, but that's not the one we're talking about. By consistent and explicit, I mean that he used language that was very descriptive. He wasn't using any flowery, ambiguous language. He was very direct. Now, we can do this in our code. We can make sure that we're writing like small focus functions, things that have one purpose and do that purpose well, rather than having functions doing lots of little things and lots of nested conditions and loops in that. We can make sure that we're using logical and predictable flows. These all enable us to create that simple and repetitive structure similar to what Eric Carle did in his book. And we can make sure that we're using consistent naming and styling, kind of borrowing from those ideas of consistent and explicit language. I often see code where people will use very ambiguous language for variable names. People kind of fall on the easy, like, well, I'm going to just fetch some data from a database and I'll just put it in a variable called data. I mean, data doesn't mean anything. If you're fetching products out of a database, just call your variable products. It's more descriptive. And it's surprising that actually removes some friction that you might not realize is there, but it is. And when you're reading over the code base, they can actually really start to impact your understanding and make you start to become disorientated. So, why are these things reducing that cognitive load? Now, a moment ago, I said that we use our short-term memory when we read. And I said that we remember typically 4 to 7 items every 30 seconds. Now, if you feel like that doesn't describe you, you feel like you can remember far more than that, I hate to break it to you, but you're probably not a superhuman. The chances are that your brain is spotting patterns, and when it does this, it can utilize concepts like chunking. And chunking is this idea that your brain will find similar things and group them together, and it's that grouping that you're remembering. And this is really important to recognize, because we often say in code, do not repeat yourself, But actually, when it comes to the overall structure, architecture of your code, that repetition is actually important, because that's what's going to kind of unlock this ability for your brain to kind of hold more information while it's reading through. There's also this idea of recognition over recall. This is what enables us to scan over text more quickly. Like if you're reading a novel and you can scan read it fast, it's probably because your brain is managing to just recognize those patterns rather than having to recall and stop and think about every single word. What is this meaning? It's kind of like muscle memory. So if you take as an example someone playing a guitar. When you learn the guitar, you have to learn to use your two hands in different ways. One to form chords on the fretboard, and the other hand strum. And when you first start out, it sounds terrible because you have to stop and think what each hand is doing. But over time, you build this muscle memory. You kind of just instinctively start doing things. And it's kind of the same when it comes to reading. When there's that repetition, that familiarity, we can start to skip over things and understand things more easily. Bad code is problematic. When we have bad code, we're far more likely to introduce bugs, insecurities, performance issues. It's harder to maintain and more time-consuming, and as a result, more costly. So, I want to move on a bit from the two books and talk a little bit about legacy code. And I've called this section the new legacy code, because this is where AI comes in a bit. Because this is not a pro or anti-AI talk, but I think we need to recognize that AI has this potential of generating a lot of legacy code very quickly for us. Now, legacy code is a bit like picking up a copy of Ulysses halfway through in a random chapter. You've basically got no idea what's going on. So if we were to try and define legacy code, we might describe it as old, no longer actively maintained. Perhaps the original author has left the business or is busy on something else, and even if they are available, they probably don't remember what they wrote those years ago. It's also messy, and I think it's that messy part that's the important bit to recognize here. Because when I've talked to colleagues, if they're having a bad day, and I ask why, and they might get the response, well, I'm working on a legacy project, it's a nightmare, I don't understand it, it's really hard to pick up. But then I could speak to another colleague who might be having a really good day, and it turns out they're also on a legacy project. But because it was well written in the first place, it's easy for them to follow and understand and just jump in and work with and extend or fix whatever's needed. It's the messy code that's the problem. I started putting this talk together about a year ago. The reason I started thinking about the readability of code and kind of like why it matters for the way that the brain works is because I was talking to a colleague. They were having a lot of problems finding a bug in some code, and so we paired up, and I got them to talk their way through what was happening. The code was long and deeply nested, and it became apparent very quickly that they were getting very lost and disorientated. They didn't really know where they were as they were going through it, and so we tidied it up. And once it was a bit more linearized, a bit more broken down, suddenly the bug was very apparent, and they were able to go off and fix it, and everything was fine. But it sounded like this was a legacy code problem, and it wasn't. They'd only written the code a couple of weeks before. Essentially, they had written it like that stream of consciousness, just putting their ideas down and not stopping to think, how does this code read back? Make sure that it's readable future-proofing it, essentially. So maybe we need to redefine legacy code as just messy code. And if that's the case, then there's a risk that AI is generating a lot of legacy code for us. Now, vibe coding came up a few times this morning. I just want to kind of make a bit of a distinction between vibe coding and AI-assisted engineering. So by its definition, vibe coding does not require a programmer. By definition, you do not look at the code if it's been vibe coded. It is literally, you prompt AI to generate you an application, you run it, that's it. AI-assisted engineering requires a human, a real person interacting with the AI, instructing it, kind of having a conversation almost, essentially paired programming. And I think, this is where we want to be at. This is where we bring the value into it because, our understanding of code is as important as it's ever been. And we're the ones that need to come in and put that human angle on, because essentially we're building for users, real people, and AI doesn't have that lived human experience. Now, this is not scientific data. This is just to illustrate a point, but based on that idea that vibe coding does not require a programmer, that kind of puts our understanding right at the bottom. So the more you rely on AI to generate something, as soon as you vibe code entirely, you can't understand the code because you're not looking at it. You can't understand something you're not looking at. We need to recognize the importance of finding that, if we're going to use AI, to find that middle ground of interacting with it and understanding it. AI produces draft versions. It's not production ready until we've engaged with it, verified what it's doing, and ultimately made it more readable, making sure that we're making it so that people can understand what's going on. Often you hear people say AI is a bit like a junior dev. I also kind of want to make the point that I do agree it can work like a junior dev, but there's something that a junior dev does that an AI doesn't, and that's junior devs learn and develop through experience, and they've already come to the table with experience because they've lived life and know how things work and what things need to take into account. So, like James Joyce and Eric Carle, we as developers, software engineers, we are creatives. We don't always talk about ourselves like this. Programming doesn't feel sometimes like a creative medium, but it is. We can write code in any way we like. We've established we can write really messy code or really clean code, but even if you're writing clean code, you can do it in many different ways. And we're also the ones that are coming and bringing creative ideas to solve problems. And, we're writing code for humans, not machines. I think it's really important to understand and recognize, because even if we're using AI, we're still getting it to produce code that's human readable. If we weren't going to do that, if all that mattered was the code that it ran on a machine, we'd just go straight to machine language. Why bother with JavaScript or Python or PHP or whatever language you're working in? Ultimately, we are writing code so that humans, like the ones that we looked at when we were talking about developers earlier, that they can read and understand that code. And ultimately, we're accountable for what we produce, no matter how we do it. So there was a lot of talk earlier about being responsible for our code. I think we also need to recognize we need to be accountable. That's a slightly different concept to responsible. Ultimately, what we're producing, we need to be able to defend. And that's where that verification comes in. And again, let's make our code really easy to read and understand. So, I want us all to be a little bit more caterpillar in the way we approach writing code, no matter how you're producing it. Look at the lessons that we can learn from a very hungry caterpillar in Ulysses. We can keep our functions, small and focused. I don't mean like ridiculously small, but that they're doing one thing, they have like one responsibility and they do that well. And we want to avoid that deep nesting. We don't want to be recreating that stream of consciousness concept where code becomes really easy to get lost and disorientated in. We want to use meaningful names, the way you name your variables, functions, classes. It needs to be something that actually makes sense. I mentioned about the example of like getting some products out of a database. Another reason I really care about this is when I first ever started out, I was at university, and the professor that was teaching computational physics would give us a code base that he'd written in the 1970s, and I'm not that old, but we had a much more modern version of the language at the time that was more capable than some of the limitation of this language. But one of the limitations of what his code had been written in meant that you could only have variable names that were no longer than 4 characters. It just ended up random strings, really hard to read. So, we don't have those limitations. We can write meaningful names. We can make sure we don't use magic numbers and things like that. Use that explicit language. And then we want to make sure that we're maintaining consistent styling and following consistent design patterns, building in that repetition that kind of creates that consistency, that reduces that context switching that can become so problematic in keeping us focused and able to read through the code with ease. What we don't want to be doing is creating code like Ulysses. Now, I think we established no one in the room had read Ulysses, which is lower than normal when I've given this talk. Just to say, normally there's one person who's come in and is disappointed that I'm not giving a detailed description of the book. But if you were to go out and read it now, you'd probably go and pick up an annotated copy. Annotated copies of novels basically have footnotes in, they have descriptions, explanations to help you follow what's going on. We can do this in code. We can write comments. And often when you use AI, you'll see AI produces a lot of comments for the code to explain what it's doing. But this is often regarded as a code smell. Good, well-written code should describe what it's doing itself. It should be easy to follow and understand. Those comments are necessary, and a problem with comments is comments have to be maintained. If you've got comments in there, they become your code. You have to update them as much as anything else in that code base. And this isn't to say comments are bad. Comments have their place. If you're trying to explain why the business logic, then yeah, use comments. But don't use them as a crutch to hold up difficult-to-read code. What you really don't want to do is end up with a comment like the one I'm about to reveal, which comes from a genuine code base that I have seen many years ago, and that's this one. When I wrote this, only God and I understood what I was doing. Now, God only knows. Good craftsmanship has always been important in our industry. I'd say it is as important, if not more important now, even if we're changing the tooling that we're using to write that code. Ultimately, it's real people engaging and working with it, so we need to make sure that readability is still something that we're talking about and still something that we're actually going out of a way to implement. So be a bit more Caterpillar and less Ulysses. Thank you.